Okay, I'll continue on chapter 3, part 1, which is the bioremediation for organic contaminants for enzymatic degradation. Previously, you had done on this class activity. Okay, I will review and I will respond in CN. I will put my comment in the CN. Okay. So today we proceed with the recent advancement in biodegradation of lignocellulosic waste. Okay, as you know, lignocellulose is the raw material for containing lignin, cellulose, hemicellulose. Okay, so there are potential application for all this kind of waste, lignocellulosic waste. Okay, there are potential for application of bioenergy generation. Bioenergy here commonly as biofuels. Okay, where cellulose will be converted into sugar, then fermented into biofuel. Okay, those bioconversion are using microbial enzyme. Before they can proceed, before the lignocellulosic waste can proceed, they will need to go pre-treatment. Okay, there are a few pre-treatments approaches. They have alkaline hydrolysis, acidic hydrolysis, mechanical pretreatment, okay, which is physical pretreatment, and then one of it is enzymatic hydrolysis, okay, where they use enzyme. The most effective pretreatment at the moment seems to be ionic liquids, okay, ionic liquids, solvents, due to their effectiveness and less toxic in nature. Okay, since 2010, many researchers studies on the ionic liquids. For enhancing the biofuel production, there are studies use microaerobic conditions. Okay, they induce microaerobic conditions to enhance the methane yield. Various of lignocellulosic waste, okay, the wheat straw. Some of it is rice straw, okay, and then some of it using the corn waste. Okay, another study, they improve the yield, the methane yield, through bio-augmentation of this species. Okay, so basically involving the microbial enzyme. Okay, apart from that, some researchers degrade lignin using certain specific microbe. Okay, these researchers, they degrade lignin using Pseudomonas. Okay, with the addition of glucose as the substrate. Another study lignocellulose degradation of sewage sludge. Okay, in bio drying condition. So the lignin degraded simultaneously. Okay, lignin, cellulose, and hemicellulose. The xylanase pre-treatment can also enhance the thermal stability of the cellulose. Okay, so basically you will have bioenergy as biofuel, specific microbe to enhance the methane yield. Okay. And before they can proceed to the bioenergy application or any bioconversion, they will need to go through the pre-treatment method. Okay, the pre-treatment method. Okay, so basically biofuel, which is the bioenergy, and also the application of microbial enzyme to degrade the lignin. Okay, so this is the function of rot fungi in biodegradation. We focus on two types of fungi, rot fungi. So basically we have white and brown rot fungi. White and brown rot fungi, okay? Some white rot fungi have the capability to completely mineralize all lignocellulosic wall. Okay, white rot fungi. Whereas brown rot fungi can be recycled from softwood forests. Okay, brown rot fungi, you can recycle them. So there are different strategies for the white rot and brown rot. White rot, they can degrade both lignin and polymers, whereby the brown rot can only act on cellulose and other polysaccharide. So brown rot only focus on cellulose and polysaccharides, brown rot. White rot fungi can degrade lignin and other polymers. So basically, white rot fungi is more applicable to the lignocellulosic waste. Yes, CO2 and bioenergy, the biofuel. Okay, the rot fungi pre-treatment. It proved to be an effective method for energy saving during the mechanical pulping process for pulp and paper industry. So in pulp and paper, you will need to treat the lignocellulosic material in order to get the pulp. Pulp here, it refers to cellulose. Okay, pulp is equivalent to cellulose. So in order to extract the cellulose out, you will need, you can use this kind of rot fungi for the pre-treatment. Once the pulp is extracted, the lignin will be the waste in the black liquor. After hydrolysis of the lignocellulosic, lignin will be degraded into solution. Okay, into solution. So that biodegradation of lignin, as we had gone through previously, you have specific microbe that can focus on lignin, because lignin is the one of the recalcitrant molecules, right? Okay, for the industrial applications, there are a few example over here for enzyme production, where recently, if you notice, in detergents, they include enzyme. I don't remember the brand, but some of them use enzyme technology in their detergent to remove sorry, to remove stains, improvise to remove stain, brewing, paper making, and fruit juice. Okay, so this type of enzyme, they will specifically target on the stain, so it will be easier to remove the stain. Okay, for animal feed, the lignocellulosic enzyme applicable in a pre-treatment process in animal feed. Okay, they use the lignocellulosic enzyme to pre-treat the animal feed, the grass, perhaps the their feed lah, before the animal consume. Okay, to improve the digestibility of the feed. Once the animal digests, so it improves the digestibility process in their stomach. Xylanase and beta-glucanase have been used extensively in the monogastric feeds. Okay, so this one, it helps the animals to proper digest of the lignocellulosic feed. Okay, if they don't properly digest, the animal will feel some gastric pain, okay, or bloating. So they implement the lignocellulosic enzyme to the feed before giving to the animal. Okay, for antioxidant production, the lignocellulosic enzyme, which derive from various fungi, are reported to improve the antioxidant properties of foodstuff, along with the formation of several antioxidant compounds. So they improve the antioxidant properties. For example, the soluble dietary fibers of date fruit fiber concentrate. So it can enhance the action by this type of enzyme. Okay, in date fruit concentrate, they implement this type of enzyme to improve the antioxidant properties.
Can we say that fungi those understand the wide concept of this because and that's why it can break the lignin.
It helps for on the pre-treatment for the lignin degradation, lignocellulosic waste degradation, pre-treatment method. Okay, the figure here, in general, from the lignocellulosic material converted into products. Okay, here products, this is example of products, the acids, the sugars, and also the alcohols. If you go through in details of this paper, you can read through the details on their application. Okay. For the biofuel, we know that the origin of biofuel comes from sugar, where the sugar comes from the cellulose. Cellulose, hemicellulose can be converted into sugar. Cellulose then turned into xylose. Okay, then fermented to form the biofuel with specific strain of microbe, which is this one. This is commonly used, Saccharomyces cerevisiae. Again, before the producing the bioethanol, the lignocellulosic biomass must be pre-treated to remove the lignin, because we want the cellulose and hemicellulose only. Several chemical and biological processes are reported. Okay, as I mentioned earlier, you have chemical, which is the acid, alkaline pretreatment. Then the mechanical is, the physical one is mechanical pulping or steam pulping using steam. Biological is the enzymatic hydrolysis. Okay, this one paper mentioned that for improvement and further generation of cost-effective biofuel, genetic manipulation can play a key role. That means I assume this one like bio-augmentation of the microbe. Okay, in enhancing the ability to manipulate the biosynthesis and deposition of lignin. So perhaps they can manipulate the genetic of the microbe, specific microbe, to enhance the ability of the degradation of lignin, instead of perhaps required, let's say, 24 hours for the degradation, or perhaps they can manipulate to be like 12 hours to reduce the time, then reduce the cost. Okay, so we are done for chapter 1, chapter 3, part 1, enzymatic degradation. Any question? Just go through. Okay, so basically this subtopic, you are introduced into various type of enzyme from lignocellulosic waste. Okay, last time we have gone through the lignin modifying enzyme. There are a few, LIP, MNP, the lacase, hemicellulase, and a few more. Okay, so from there, you'll need to know how is their origin and how they react on the substrate. Okay, then you are introduced into the recent advancement in the biodegradation of lignocellulosic waste. Okay, this one we focus on enzymatic degradation only. Okay, so basically this industrial application just focus on these few: enzyme, animal feed, antioxidant, and biofuel. Okay, there are a lot more, but you can focus only to these four. Okay, you want to take a break before I start the new subtopic? 5 minutes break. Okay, we proceed to plastic waste, biodegradation of plastic waste. Got? For my part, one assignment. Dr. Lai's part, one assignment. Yeah.
Less.
How many percent?
10% for
Huh? 20%. So mine 10, Dr. Lai 10. Different part, different CLO coverage.
That's the thing.
Okay, now we proceed for part 2. Biodegradation of plastic waste. So plastic itself, we have a few types of plastic. We have non-biodegradable, biodegradable. Okay, for the non-biodegradable, basically it is not easily degraded. It is a synthetic plastic. Not degraded easily by biological means. Okay. Or they take a very long time to degrade. So as you know, now they are moving into the biodegradable plastic. Okay, the Tesco, Giants all move towards the biodegradable plastic already. Synthetic non-biodegradable plastic comprise both bio and fossil-based plastic. Fossil-based, petrol-based. Okay, there are perhaps a small percentage on the bio part only. For example of non-biodegradable plastic, we have PE, terephthalate, PVC, PS, polystyrene, polypropylene, KHDPE, commonly used for packaging, carry bags, marks, everything. This application is due to their durability, longevity, stability, and poor waste management. Synthetic can cause pollution. Okay, so as you know, the plastic pollution nowadays is very high. So that's why everyone turning into biodegradable plastic or reduce or refuse plastic usage. Polyester is plastic or not? Polyester. Plastic. Okay. Clothing, the apparel is considered plastic pollution as well, polyester. So that's why I've read one statement. Fashion is one of the most, one of the most that contribute to the plastic waste as well. Fashion industry, because they produce many types of apparels. Every season they have new fashion, right? So some of it from polyester, one type of plastic. Unless they are using cotton, then cotton consider okay to the environment. Okay. Now biodegradable plastic, where you have Plastics that are degraded by living organism that can easily be degraded. The time required to completely degrade the plastic depends on the various factors, like for example, the type of material, organism, temperature, okay, the condition of the environment, temperature, moisture, and the location of the decomposition. The properties of the plastic itself also plays the role, like the functional groups, okay, the mobility, the molecular weight, the additives. Because the biodegradable plastic, we cannot use 100% biodegradable material. It will jeopardize the strength of the plastic. So somehow they will need to add some additives to improve the strength. Okay, for the biodegradation of plastic, involve enzymatic, non-enzymatic, aerobic, and anaerobic process. Okay, the enzymatic we have gone through few type of enzyme. The aerobic also few types of microbe that is suitable for the process. Okay. Okay, apart from that, we have another type of biodegradable plastic. We have bio-based, okay, bio-based and fossil-based. Bio-based basically from various renewable sources like biomass waste, whereby the fossil base comes from the crude oil or the natural gas or coal. Okay, so the bio-based, for example, polyhydroxyalkanates, PHA, and polylactic acid. This one polylactic acid, PLA. So this one basically the bio-based biodegradable plastic. For fossil-based, basically the PE succinate. This is biodegradable, but they incorporate with the fossil base as well. Okay, and the PVA, polycaprolactone, biodegradable polymers. This one normally not used for the carry bag plastic. This one perhaps the automotive applications. Okay, there are many types of application. The automotive, the medical parts. Okay. Okay, what are the hazards that cause from this plastic waste? What do you think? What are the hazards? Sea pollution, bioaccumulation of the microplastic. What else? Hazard from plastic waste. Here, plastic waste, so we can combine the biodegradable and non-biodegradable. Sea pollution, so it will affect on the aquatic life itself. Okay, other than that? Huh? Air pollution, yes. If the plastic being burned, then it will pollute the air. Other than that, certain type of plastic is carcinogenic. What do you understand of carcinogenic? Cancerous, can cause cancer. Okay, so that is also one of the hazard from plastic waste. Usually from fossil base. Okay, some of it involve the aromatic ring. Benzene is carcinogenic. Okay, and some of it they are mutagenic. What do you understand from this term? Mutagenic. Cause mutation to the cell. It also affect on the reproduction. Okay, so sometimes the reproduction of perhaps the animals, it affect from the plastic itself. Okay, apart from other types of chemicals, after other types of exposures. Okay, how to degrade this plastic waste? There are a few types of degradation process. We have thermal degradation. Okay, certain type of plastic suitable to be degraded thermally. Okay, like chlorine containing plastic, okay, PVCs, and then but fluorine containing plastic like polyvinylidene, it will release the hydrogen fluoride. So it is not quite suitable for thermally degradation. Hydrogen fluoride. What is the hazard of hydrogen fluoride? Affect what? Huh? Ozone layer. Huh? Sorry? What? Catch fire. Catch fire. Flammable. HF flammability not that high. Flammability. Okay, there are specific hazard can caused by the hydrogen fluoride. Some plastic polymers can degrade via chain scission method. That means cutting the chain. They have a long chain, so can cut the chain. There are specific method of that. Chain scission method. Okay, they undergone the depolymerization. Okay, like this type of plastic. Partial depolymerization like polyester, PS, and polyurethanes. Okay, so these are the various harmful substances emitted from plastic products. Brominated flame retardants, okay, phthalates, bisphenol A, BPA, bisphenol D, dimethylchloride. Okay, BPA, if you have small babies, if you have small sisters and brothers, the bottle, the plastic bottle, the milk bottle, nowadays they are producing non-BPA. Yeah, if you notice, no BPA. they are hazard of BPA. So that's why they remove the BPA content from the plastic. Okay, so the rest you can read through. Okay, these are a few more methods for plastic degradation where we can have photo-oxidative degradation. Oxidation using photo. Okay, photo-assisted oxidation degrading due to action of light. Okay, degradation or decomposition of polymer due to action of light. There are only specific type of plastic. Like if you use this chair also comes from plastic. So this one is quite hard plastic. It is not easily degrade by photo. Okay, so certain type of plastic only can degrade using photo. Like carry bag plastic, that one can be degraded by the photo. Okay. Thermal degradation, where it involves thermal and UV light to initiate the polymer degradation. Okay, to seep through into the chain degradation. Okay, thermal here it involves on high temperature. We are talking about high temperature to break the chain for the degradation process. Degradation above 200 degrees C causes chain scission. Okay, and again, it depends upon few factors of the plastic and also the environment of the degradation location. Okay, there are a few byproducts. Yield obtained as a product of these thermo-oxidative methods are this one. Okay, so I think few years back for the PDP, which the theme is formation of acetaldehyde, I think. So these are the few methods that they can use to produce acetaldehyde, the thermal degradation of the plastic. Acetaldehyde, it has its own function. Okay. Did you notice few years back, Malaysia has issued to be a dump site for plastic waste? You notice not? Few years back, there are issue. Other country dump plastic waste here. Okay. Apart from that, actually, in my opinion, that plastic waste is to be used in this kind of production, this kind of chemicals production, because perhaps in Malaysia, they are not enough to produce in large amount of this kind of chemicals, where they can use plastic waste, but perhaps in Malaysia, we don't have proper management on the plastic waste. So this kind of acetaldehyde, for example, they only use PP, polypropylene. So you will need only that certain type of plastic to produce acetaldehyde. But in Malaysia, we don't have that good system to only collect PP, certain types of plastic like PP and PE, PVC, right? Okay. To produce in bulk, they need a lot of raw material to degrade in order to produce acetaldehyde, for example. So that's why if you have heard, there are also illegal dumping site and illegal plastic waste recovery site. They are making a lot of money also to supply this type of plastic waste into certain company to produce this kind of chemicals. There are companies use pure raw material, but then there are companies use waste. Okay, so next we go for catalytic degradation, where you use catalyst to degrade the hydrocarbons. Okay, like this specific type of plastic, polyolefins such as PP, PE, PS, okay, can be effectively degraded by catalysts into oils and gases. Okay, so this kind of plastic waste can be recovered into oils and gases and can be sold. Most of the time, they use pyrolysis process for this kind of plastic waste. Okay, that means the catalytic degradation combined with the thermal degradation. Pyrolysis at high temperature. Pyrolysis waste requires lower temperature. Okay. The definition of lower temperature here means around below 500 degrees C. Okay, because pyrolysis, it has its specific temperature for the pyrolysis stage. Commonly used is the zeolite. Okay. Another thing is the biodegradation. We have gone through this one in previous chapter where you can use a few types of microbes, fungi, bacteria to degrade the plastics. Okay, under either aerobic or anaerobic condition. Okay, biodegradation can occur by one or more of the following methods. Loss of mechanical strength or change it in surface properties, enzymatic degradation, microbial assimilation, and backbone change, breakage. Okay, these few types of biodegradation, we have gone through the enzymatic degradation. Okay, the rest, we have not touched it yet. Okay, so what I want you to do is this biodegradation method. You have this few methods of here. Okay, this one. Enzymatic degradation, okay, change the surface properties, microbial assimilation, and backbone chain breakage. Okay, from this one, we have, you have 3 groups, right? Okay, do it in groups. Choose one of it. Color of the words. Okay, why don't you inform earlier? This is the last slide already. Okay. Wait. I will upload this in CN, no worries. Okay, so these 4 methods, choose one. Make sure don't clash, don't use the same method. And then just do it in one slide of PowerPoint or one slide, do it in poster form. I mean, you have what is the definition, okay, and then how is the mechanism, what is the target action. Describe the 4 methods. Choose one lah, describe one method of it. Okay, so describe one methods only. So each group, one methods, and we will have 3 methods already. Okay, so for you only left one subtopic. Next coming class,